All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 36 is on the screen. Let's get started, please. By now, you should be able to do all of those by yourself. So, I'll give you guys about 7 minutes, and let's get started. Also, after that, get a Cornell note. We are moving on today, so stay focused. All right? All right, copy it. All right, we good? All right, do me a favor, show your neighbor, see what they got for the warm-up. They should be at least halfway done. Show your neighbor, please. All right, here he goes. 1A. How do you break down 18 and 24? Let's go with Jacob. What did you write for 18 and 24? So you said 6 times 3 and 6 times 4? Are you good? All right. Giant 1. So, correct answer, 3/4. Hands if you got that. Very good. Go to 1B. Tell your neighbor what you got for GCF for the numerator. What is GCF for the numerator? What are the factors? Then Jacob's going to pass someone. Carlos not here. Miguel, GCF. 2. What else? X, I heard. Okay. That leaves us with X minus 5. How about factors for the denominator? Tell your neighbor what you got for factors for the denominator. Then Miguel's going to pass someone. Leo? Bless you. X plus 5, X minus 5. Hands if you got that. Bless you. That is correct. All right. Do we have any giant ones? Yes, the X minus 5. And that leaves us with 2X over X plus 5. All right, number 2. Factors for number 2. Tell your neighbor what you got, and then Leo's going to pass someone. What are my 2 factors for number 2? Scarlett, factors for number 2. Yes. What 2 numbers? Negative 6 and 4. So X minus 6, X plus 4. Hands if you got that. All right. Number 3. 2 factors for number 3. As you are turning to your neighbor to let them know, let me set up my Power Rangers for that one. 4 times 6, that's 24. 11 down here. 2 numbers multiplied give me 24. Then you add them, give us 11. That's 8 and 3. But we have this 4 right here. So with that said, tell your neighbor the 2 factors for number 3. Then Scotty's going to pass them. All right, Scarlett, pass someone. Who? Oh, Natalia Castro. What'd you get? First of all, Can we reduce this more? Divide by 4 top and bottom, and it's 1 over 2. 1 over 2. So my first factor is x plus 2. Very good. Can we reduce the second fraction? No. So my second factor is 4x plus 3. That is correct. Number 4. I need this in y form. Y equals to what? Show your neighbor. What did you get for that one? Y equals to what? Then we're going to pass it to someone. Y equals to what for number 4? All right, let's pass someone. Geo. Y equals, start with the x first, negative 2x plus 3. Hands if you got that. That is correct. If we substitute negative 1 there, y equals what? And if we substitute 0, and if we substitute 1. So substitute negative 1, what do we get, Geo? Yes, but y equals 5. That is correct. Y equals 3. Y equals 1. Good recovery. Bless you. So far, so good. And the last one, number 5. First, I'm going to break up the two denominators. What are my factors for 15? Pass them 1, Geo. 3 and 5. 3 times 5. How about for 6? 2 times 3. Bring down the 2. Bring down the 5. So to get the common denominator, what do we need over here? Over here that this one has. No. What do we need over here that this one has? The 5. So multiply top and bottom times 5. So now what does the first one need that this one has now? The 2. Multiply times 2, top and bottom. So, common denominator. 2 times 3 times 5, that's 30 and 30. 2 times 2 is 4. 5 times 5 is 25. So we end up with 30. Numerators, so that's 29. Hands if you got that by yourself. Alright, we're getting there pretty quick, so I'm trying to give you guys plenty of practice for that. Copy the agenda. Warm-up 36 done. Rational functions. We're moving on today to rational functions. But we're going to start with equations before we transition to functions. And tonight's home plate, play sheet 10.7b, evens only. So, as you copy the agenda, go to Canvas, turn in your home plate from last night, please. I'll give you guys some time. And go. And once again, just a reminder, this session is being recorded. And so that you remember, and I remember, and everybody remembers that goes and watches this video on my YouTube channel. If you are starting to struggle with some of the concepts, I'm here in the morning from 7:15 and on. Come in for tutoring because it's starting to snowball little by little. The concepts are going to start getting rigorous as we progress. All right? So, copy the code to access the home plate for tonight. Write that down. Y2 DRJ. Write that down. Y2 DRJ. Y2 DRJ. Y2 DRJ. So, last night's home plate looked something like this. Tonight's home plate look something like this. Look at that. Look at that. We're no longer with the baby steps. Now we're moving on. Let's go. Go. Oh, yeah, we got this. All right. So, get a Cornell note ready, please. I can solve rational equations. I can solve rational equations. I can solve rational equations. Now, I give you guys a couple of sessions on simplifying rational expressions, and then we did also excluded values as well. And as we're moving on, like I said, it's starting to pick up the pace, so stay focused. So, I can solve rational equations. You do need a Freire model. Here we go. What are rational equations? Rational equations are an equation that contains one or more rational expressions. An equation that contains one or more rational expressions. What's a rational equation? An equation that contains one or more rational expressions. What is a rational equation? An equation that contains one or more rational expressions. Bless you. Can you picture it just by the definition? Picture it. Rational equations are equations. Can you picture an equation? Yes. What's so specific about that? Tell your neighbor what's so specific about an equation. It has what? Yeah, an equal sign. All right. But then it says contains one or more rational expressions. Have we been working with rational expressions? Yes. They are what? In one word. Fractions. Yes? So it should look something like this. Copy those. 6 over g plus 4 equals 2. 2x minus 14 over x squared minus 15x equals 1. 2x plus 6 over x squared plus 5x plus 6 equals 1 over x plus 3. All those are rational equations. Because according to the definition, they are equations. Let's see. You guys said equal sign? Yes. Equal sign? Yes. Equal sign? Yes. Rational expressions, one or more. Do you see rational expressions? Here's one right here. Here's another right here. This one has two of them. Yep. That's why all of those are rational equations. All right. So if those are rational equations, why are these not? Before you copy those. Tell your neighbor why these three are not rational equations. Tell your neighbor. All right, check with your neighbor why, and then we're going to have Diana get us started with this one, why this one is not a rational equation. Then from there, Michelle's going to tell us about this one. And then Renzo's going to give us the last one, why the last one is not a rational equation. All right, Diana, why is this one not? No equal sign, okay. How about this one, Michelle? No fraction, no equal sign, that is correct. How about this one, Renzo? It doesn't have the fraction, yeah, it doesn't have a fraction. So, hashtag, it has to be an equation, and hashtag at least one rational expression or at least one fraction. Write that down, please. Okay, we good? Yes, Mr. Q. All right, good. All right. So, we know what rational equations are, what they're not. Today we're starting with these simple ones. And that's why I gave you guys plenty of practice with expressions. So, with that said, underneath your prayer model, I want you to write steps. Today I am going to have you write the steps down because it's a long process for today, and I just want to make sure we got it. Underneath your prayer model, write steps. Step 1. Write this down. When the rational equation is a proportion, cross-multiply and solve. When the rational equation is a proportion, cross-multiply and solve. Above where you write proportion, or below it, in parentheses, write fraction equals fraction. Whenever you have a fraction equal to another fraction, that's called a what? A proportion. Whenever you have a fraction equal to another fraction, it's a proportion. Whenever you have a fraction equal to another fraction, it's a proportion. Whenever you have a fraction equal to another fraction, it's a proportion. Whenever you have a fraction equal to another fraction, it's a proportion. Whenever you have a fraction equal to another fraction, it's a proportion. All right, tell your neighbor what a proportion is, please. Yeah, fraction equal fraction, okay? All right. But then you're like, but what if it's not, Mr. Q? Well, look up. If it's not a proportion, write that down. If not a proportion, I'm going to give you 3 different steps. Step number 1, you identify the least common denominator. Step 2, multiply the entire equation by the L.C.D, or the least common denominator. Step 3, simplify and solve. So once again, you look at the equation. If it's a proportion, that means a fraction equal to a fraction. You cross-multiply and solve. If it's not, you need to find the L.C.D, multiply the entire equation by the L.C.D, simplify and solve. All right, let's get this show on the road. Y'all ready? All right, example number 1, write this down. You might have to turn your page over and start in the back. Example 1, solve algebraically and identify excluded values. They give us 5 over x minus 2 equals 3 over x. Write that down, please. 5 over x minus 2 equals 3 over x. Example number 1. 5 over x minus 2 equals 3 over x. Let me zoom in. All right, we're looking at a rational equation, is that correct? However, what specific equation is this? A fraction equal to another fraction. What is that called, people? Proportion. So whenever we have a proportion, what is the step that I gave you? To cross-multiply and solve. Is that correct? So check this out. I always like to start wherever there's an x by itself. So I'm going to go 5 times x. What is 5 times x? 5x equals. Next, 3 times x plus 2. That means we need to multiply the 3 times the x and the 3 times the negative 2. So that gives us 3x minus 6. That's what we call cross-multiplying. So far, so good, yes? From there, what are the next instructions on your steps? It said solve, right? All right, so let's solve. Line down the equal sign. I need to get all variables to one side. So I subtract 3x, subtract 3x. I end up with 2x equals negative 6. What do I do at the end? Divide by 2. X equals negative 3. Label this and write solution. Solution. All right. So what does that mean, guys? That if I substitute 3 here and 3 here, we're going to have a fraction equal to another fraction. They should look the same. All right. However, they ask us to find the excluded values as well. So I'll write on the side EV. Let's see how well you remember from what we did these past 2 days. Tell your neighbor how to find the excluded values, and Julian is going to enlighten us. How do we find the excluded values? How do we find the excluded values? All right, Julian, how do we find excluded values? He said, take the denominators and set them equal to 0. Tell your neighbor what I just said, please. Denominators equal to 0. So what our first denominator is, x minus 2 equal to 0. What is the other denominator? X equal to 0. Let's solve. Oh, this one's already solved. Let's solve this one. Plus 2 plus 2. X equals 2. So my excluded values are 2 and 0. What was our solution? Negative 3. Is the solution any of those numbers? No, we don't need to worry about any of that. From 1 to 5, how comfortable are you with this? Where are we at? 5, 4, 3. 5, 4, 3 is okay? Yes. The second denominator? First denominator equal to 0. Second denominator equal to 0. Look up, guys. Look up. You write the denominators equal to 0. This one equal to 0. So since it's already equal to 0, it's already solved. There it is. All right? So let me send you a screen so you can send me your notes. Example 1Q. Copy that. Example 1Q. 1 over x equals 3 over x plus 4. I'll give you a head start on that one. It's very similar to the one we just did. Then find the excluded values, and then send me your notes to see what you did. All right, here we go. Check with the neighbor really quick to see where they're at. I'm going to go over this one just to make sure you got it. All right, looks like Autumn's already done. Very good, Autumn. All right, here we go. Question. Do we have a fraction equal to another fraction? Yes, Mr. Q. So I'm going to cross multiply. I'm going to start with my x. What is 3 times x? That's 3x equals 1 times all of that is x plus 4. From there, we need to solve this. Line down the equal sign. All x is to one side. I subtract x, subtract x. That leaves me with 2x equals to 4. Divide by 2, divide by 2. X equals 2. Hands if you got that by yourself. All right, and that's my solution. But then we need to find the excluded values. How do we find our excluded values? Let's see, let me call on Julian. How do we find our excluded values? Set the denominator to 0. My first denominator is x, so I write that equal to 0. The other one is x plus 4 equal to 0. And solve. This one's already solved. Minus 4 minus 4. X equals negative 4. So my excluded values are 0, negative 4. Hands if you got that by yourself. All right. So now, are any of the excluded values part of the solution? No, so we don't have anything to worry about. Send me your notes, please. All right, well, enough of little baby games. Let's pick up the pace. How about them apples, yeah? Let's crank it up. All right, copy this one. Example 1, Super Q. X plus 1 over x minus 2 equals 4 over x minus 3. Copy that? So x plus 1 over x minus 2 equals 4 over x minus 3. All right? So here we go. I'm going to pause the music for right now. Question: do we have a proportion? Yes. One fraction equal to another fraction. Okay. So here we go. Cross multiply. In this case, we don't have x's by themselves, so I'm going to cross multiply. So I'm going to multiply that times that. So to write it out first, I'm going to write x plus 1 times x minus 3. So far so good? Equals 4 times that. In this case, we can multiply the 4 times x, 4 times negative 2. So what is 4 times x? 4x. 4 times negative 2 is negative 8. Are we there so far? All right. However, for this, look up, we only wrote it out. We haven't multiplied anything. So, if you have colors, I'm going to start with blue. I'm going to distribute first the x to the other parentheses. So what is x times x? That is x squared. What is x times negative 3? Negative 3x. Now I'm moving on to the second term, which is positive 1. And I'm going to distribute to the other term again. Positive 1 times x is positive 1x. Positive 1 times negative 3, that's negative 3. Can I combine stuff? Yeah, the x's, right? So I'm going to bring down the x squared. What is negative 3x plus 1x? That's negative 2x. Bring down the negative 3. Bring down the equal sign, and bring down the 4x minus 8. All right, I'm going to zoom out. Next, to solve this quadratic equation, I need it to be equal to 0. So I need to get rid of the 4x and the minus 8. So I need to subtract 4x and add 8 to each side. Subtract 4x and add 8 to each side. So this side cancels. So we're left with 0. Look at this side. X squared. Negative 2x and negative 4x, that's negative 6x. And then we got 8 minus 3, that's positive 5. Does that look familiar? Yeah, your brain wants to do what? What two numbers multiply give me positive 5 that when you add them give us negative 6? Tell your neighbor, what two numbers multiply give me positive 5 that when you add them give us negative 6? Let's see, looks like Autumn's got it. Well, let's go with Geo. What two numbers? Negative 5 and negative 1. Negative 5 times negative 1 is positive 5. Negative 5 and negative 1, that's negative 6. And since there's no number in front of the x squared, we can use the shortcut and just get our factors. X minus 5, x minus 1 equal to 0. And the rest is history, yeah? Set each one equal to 0 and solve. X minus 5 equal to 0. X minus 1 equal to 0. Plus 5 plus 5. X equals 5. Plus 1 plus 1. X equals 1. These are my solutions. How are we doing? Have we solved these before? Yes, Mr. Cube. This is the first time I presented as a proportion. However, are we done? No. Let's find our excluded values. Tell your neighbor how to write and get started to get the excluded values, please. How do we get our excluded values? Let's see, enlighten us, please. Jaime, what do we do to find our excluded values? Set the denominators equal to 0, so that means x minus 2 equal to 0 and x minus 3 equal to 0, and solve. Plus 2, x equals 2, plus 3, x equals 3. So my excluded values are 2 and 3. Are any of those my solutions? No. All right, send me your notes, please. Let me send you the screen. All right, from 1 to 5, I'll come through you with proportions. Where are we at with proportions from 1 to 5? 3, 3 fourths, 5 3, 5 fourths, 5 fourths. All right, we just need practice. All right, so enough of the proportions. Let's go with the other one that requires a lot of fun stuff. Copy this one. You need a lot of space, by the way. Make sure you have enough space. So if you need to start a new paper, start it off. Example 2. 6 over x plus 2 minus 10 over x equals 4 over 2x. Copy that. 6 over x plus 2 minus 10 over x equals 4 over 2x. 6 over x plus 2 minus 10 over x equals 4 over 2x. All right. For this one, I'm going to zoom in just to make sure everybody's seeing what I see. Question: is this a proportion? No, it's not. Very good. Why not, Mr. Q? Because a proportion is only one fraction equal to another fraction. In this case, we have two fractions on one side equal to one fraction on the other side, so therefore, this is not a proportion. So, for this one, we need to follow the 3 steps that I gave you to write after. Is that correct? So, first things first, we need to find the L.C.D, or the least common denominator. Let me zoom out. L.C.D. I'm going to use red to make sure I follow those steps that I gave you. If you have red, use it. So over here to the right, somewhere on the right side of your paper, write L.C.D. Least common denominator. So what are my denominators? My first one is x plus 2. What is my other one? The other one is x. And what is the other one? 2x. So first things first, we need to find the common denominator for the smallest one. So look up. Look up please, or you're going to miss it. What does this denominator need from this one? 2. So then I multiply times 2. So my common denominator for these two is 2x. If we don't have any more small ones, at the end, we just multiply the big one, or the binomial, times this one. So my LCD is 2x times x plus 2. That's all you do. Are we there so far? Okay. So now that we found our LCD, we're going to multiply the entire equation times that. So let's go over here, put a big parenthesis, and we're going to multiply times 2x parentheses x plus 2. However, I'm only going to multiply all the numerators. Look up, please, and let me show you why. Because if I put this over 1, the 1 multiplies those denominators. Is that correct? That's why I'm only multiplying this times the numerators. So, check this out. I'm going to make it as easy as possible. Some of you are very distracted, and this is the one that's going to do you a number this Friday that's coming up. Tell your neighbor why. All right, thank you, Pop Party. Good suggestions. Here it goes. So let's rewrite this first. Check this out. 6, focus, over x plus 2. I want you to extend the fraction bar. Minus 10 over x equals 4 over 2x. Extend the fraction bars like that. So does everybody see that I just rewrote this right here, yes? I just made the fraction bars a little bit longer. Why, Mr. Q? Because now if I multiply this times that, I just do times 2x, x plus 2. Did everybody see what I did? All right? Again, some of you are distracted. You're missing the whole thing. Now the next one. Times 2x, x plus 2. And at the end, times the 4. That means times 2x, x plus 2. Do I need to write the 1 on the denominator? No, right? What is 1 times x squared? I mean x plus 2, 1 times x, and 1 times 2x. All right. How are we doing? Good, Mr. Q. We love these. All right, good. So, step 1, L.C.D. Step 2, multiply the L.C.D. times the entire equation. Why, Mr. Q? Because this. Look. Watch. Do you see a giant 1 in this rational? Yeah, what is it? And that leaves us with 12x. Next, do you guys see the giant 1 on this one? Tell your neighbor, what is it? The x. So that leaves us with, look up, 2 times 10, that's 20, but there's a negative here, so it's a negative 20. And distribute that to the parentheses, so that's negative 20x minus 40. Next, what's the giant 1 over here? The 2x. So that leaves us with the 4. Distribute that over here, so that is 4x plus 8. And from there, the rest is history. Let's combine like terms. What is 12x minus 20x? That's negative 8x minus 40 equals 4x plus 8. Let's get all variables to one side. I'm going to start with the smallest variable. The smallest variable is a negative variable. So I'm going to start with negative 8. So I do plus 8x plus 8x. That leaves me with negative 40 equals 12x plus 8. To solve for x, what do? Minus 8 minus 8. That's negative 48 equals 12x. Last but not least, divide by 12, divide by 12. Negative 4 equals x. Solution. Are we done? No, we need what? The EV. Hold on before you go. Just let's set this up. Leo, tell me what to write to set up my EV. X plus 2 equal to 0. X equal to 0. 2x equal to 0. If we solve, minus 2 minus 2. X equals negative 2. This is already solved. Divide by 2. X equals 0. So my excluded values are 0 and negative 2. That's how the hopefully is going to go. Those of you following on YouTube, make sure you get some work in so you can practice. See you guys next time. Peace.